Okay, so today we're going to continue with the exceptions, which I haven't really introduced last time. We'll definitely do it today. Before that, let's look at some reminders. Your lab number 1 has been released. You should really start working on that. From yesterday's in-lab demo, I talked about the so-called incremental developments for your lab number 1. And also, it would be applicable to your programming tests as well. So if you are interested, check it out. And your mock-up programming test will be tomorrow, and it'll be 5 p.m. or 6 p.m. I will send you some reminder just about the rules and some simple protocol. Since it's a mock-up test, let's make it like a real test, so you can really get the most out of it. You can wait for my communication through eClass tonight. Yeah, guys, the room is pretty small, so please, if you really have to talk, either keep it just very short or outside. I'll really appreciate that. Also, your classmate wouldn't be interrupted. Thank you so much. Okay, for your guides for the written test number 1 next Wednesday and also the programming test 1, they have been released. Nothing much to say, so please take a look and make sure you don't really miss the policy. So you can find them under the lecture site over here, written test 1 and programming test 1. I would like to just draw your attention to some part in programming test 1 guide very quickly. Of course, you will have to read it yourself, but I want to make sure you know that there's such a paragraph there. If you go to page number 4 for your programming test 1 guide, there is one section, section 5, about the rationale. It kind of explains why we have the compilation penalty for your programming submission. So we got time constraint. You'll be given 18 minutes. And also why there would be additional grading test cases in addition to starter tests, right? So I wrote down the rationale here. Please read them through. I just want to communicate my rationale with you. Make sure you read them about the policy. And then, let me go back over here. All right, and then for your written test number 1, I'm thinking about maybe to give some optional Zoom review session, maybe next Monday. I think it's more likely to be sometime in the afternoon. I will try to confirm the time. If you can attend, feel free to come, and then I'll record the session. If you cannot come, maybe check out the recording slightly later. I'll try to make the recording maybe a few hours later. If not, maybe the next morning. I'll try my best. But I'm going to confirm the time. It's more likely to be sometime around 6 p.m., 7 p.m., that's kind of the only time I have. But if you cannot make it, check out the recording, maybe a little bit later. All right. Any question about any policy, anything that we have released? We're good? Yeah, just make sure you really get started with lab number 1. It's really important. Yes?
So for like the program, will we be able to access documentation?
No. There will be no Java API needed. You will not be allowed to use any API. And also, you will not be able to access any written notes. Yes, it's good that you ask, but no. Okay. Yes?
So you did mention that programming tests kind of will be similar to the labs in a sense?
It will be shorter than lab 1, but the format will be the same.
So what would written tests be analogous to?
Written test will be, in some way, like how I conduct a lecture. You'll be asked maybe a question to check your concept. And then look at the example question I posted yesterday. That might give you some idea. But of course, make sure you study everything I've said so far, in the tutorial, in the written notes, in the iPad notes, in the discussion. I think we should understand everything that you should be prepared.
So the programming test is going to be more like they're going to be checking that we pass those test cases?
Yeah, in terms of passing which test cases, please read the guide. That one's very clearly stated about the policy. Yeah.
And then written tests will be more like conceptual understanding?
Yes, please check the guide. It's actually set over there. Okay. Yeah, so I don't need to repeat. Yeah, I think that's why I put the guide in written form, so I will stick to it. Yeah, please check them. If you still got confusion, we can talk.
You said you were going to post the mock-up test online after it's done?
Yes, since the mock-up test is going to finish around 7 p.m. when I get home, it could be maybe about 8-ish, close to 9. I'll try to see if I can post it right away. I'll try my best. If I really cannot, I will try maybe Saturday morning. How about that?
As long as for the weekend.
No worries. I know you're eager to try, so I'll do my best. Okay. No worries. That one's fair. Fair request. All right, any other question you want to clarify? Okay, if no, why don't we do a quick recap? And again, if you got any confusion about these two tests, I believe I really said everything I should really say in the guides. But if you got confusion, let me know. Maybe we can talk maybe after class today or during office hour, 3 p.m. So last time we spoke about several concepts over here, but of course that'll be the last bit of the OOP review. We'll talk about how you can manage the global IDs automatically using the static variable. So you want to make sure you really understand the difference between non-static versus static. And we talk about the pattern over here about using them properly. You can see the static counter versus the non-static ID. And we spoke about the variance where we make the non-static thing static. And that one is totally wrong. Right? We explained how wrong it was. You want to make sure you follow the approach. And we spoke about another possible mistake where we apply our programming pattern. So we got our array over here, and the integer counter that's usually non-static is now static. Right? That's also wrong. Okay? And we talk about the error, so-called referring some non-static variable in a static context. For example, here, this is a non-static variable. Is somehow referred in the static method or context. That's also considered as an error, compilation error. Also, make sure you go over them. And we suggest 2 possible fixes last time, and we criticize on one of them. So you should make sure also you understand why you should be criticized that way. And this will be our last page, which I would like to start our lecture from. And let me just see if I do have a copy of that. Yes, I do. Okay. Let me recap very quickly about what you're supposed to know. I presume at least you kind of try to struggle through a little bit, you know, the 2 terms, caller and callee. I'm going to refer to caller and callee very extensively today as we go through some concept about exceptions. Again, caller is basically the context where you're trying to call some method. Callee is basically the method call itself. All right, that's simply put. In this example here, inside C1 and 1, so C1 is the class, and 1 is the method. Inside the scope of this method here, we are making a method call, which is over here. So every line of method call is going to suggest a single caller-callee relation. All right? So here, you can see we got O.M2, and O is the context object, which was declared to be C2. So the context for the callee is C2.M2 over here. So that's a callee. It's being called. And then the caller is C1 and 1. Right? That's what we have. All right, any question about this kind of terminology here? And let's try to answer this question here together. Okay? Can a method be a caller and a callee at the same time? Is it possible? It should be possible, right? Why don't we try? I can suggest 2 possibilities, actually 3. I will talk about 2 of them, and then you guys can do the third one as an exercise, okay? Just to be fair. So you got the same material from the other section. Now, you can see that the C1 and 1 over here is the caller. Let's make a callee, right? So that will be caller, callee at the same time. So now how can we make C1 and 1 the callee? Well, try to call that somewhere. Right? As easy as that. So suggestion number 1. Let's make C1 and 1 a callee. Now, here I'm going to suggest 2 possibilities, one point A, one point B. If you want to make C1 and 1 a callee, the callee can happen in the same class, C1, or it can happen in a different class, C2. Either way is okay. Let me put both in front of you. So we can say 1.A. Let's say the same class. I can say, now I already got class C1, right? The same class. Dot, dot, dot is representing what we have already got so far for the M1, okay? That one I can ignore. Let's say we got another method in C1. Let's call that maybe N3. M3 over here. And in the body of M3 over here, I can call the same method here in the same class. I can simply say this dot N1. All right, this will effectively make N1 also a Callee. Let's take a look here. So if you look at this line here, this line, so this is referring to the current class, which is C1, right? I'm talking about some extension to class C1. And this will make M1 also a Callee. And who's the caller? Caller is actually here, C1.M3. So this is the new method I'm introducing into C1. So this will be the caller. Right? Whenever you want to make a method a caller, basically within that method, you got to call somebody else. If you want to make a method a callee, you basically want to call that method somewhere. That's how you make it. Okay, that's 1.8. Let's have another similar setup, which is I'm going to make C1.M1 a callee in a different class. Okay? So I can say 1.b here. Okay, a different class. Let's say class C3. How about that? Class C3. And over here, we have a method here. Let's call it M4. M4 over here. And in that particular method here, we cannot use this anymore because right now, M1 is in a different class, right? So we have to create some proper context objects. So we're going to say C1, some object O will be new C1. After creating it, we're going to invoke C1.M1. And then we're going to say O.M1. Right? That will be the end of this method here. Now, if you take a look in a very similar setup, so here O.M1 is basically a method call. And the context object comes from C1. So C1.M1 right now is the callee. C1.M1 is a callee. Whereas C3 and 4 is a caller, right? So this will be the caller, and this will be the callee. Basically, two similar, almost identical solutions. The only difference is I'm making C1M1 a callee either in the same class where C1, where M1 is defined, or in a different class. Any question about this? Okay, and your exercise. What I did was I'm trying to make somebody who used to be a caller and also a callee at the same time. Why don't you try? Now we're talking about C2M2 being a callee. Can you make it a caller? All right, that's something I want you to try. I'll put it as an exercise here. The second one, which will be exercise. You want to make C2 and 2. Used to be here, right? Used to be a callee, a caller. How do you set it up? Should be rather straightforward. If you got doubts, reach out. All right, any question? Yes? Let's not worry too much about recursion just yet. We'll actually definitely talk about recursion, but it would be the similar principle because usually recursion is your method calling itself, right? So the caller and callee will be the same method. But let's get to it maybe when we get to it. Otherwise, it might cause confusion right now.
What about a static method? Let's say you wanted to see, print out the screen, you know, what is the number of people in a population that should find all people.
It'll be the same. So when we talk about caller, callee, we only look at the code structure over here. So even though you got a static method there, you just say that's the method from this particular class. You'll be the same to identify the context. Will be the same. Yeah, same principle. Nothing, nothing different. All right. If no question about distinguishing between caller and callee, let's now go on to talk about something also very important, which is called a call stack. Okay? Call stack. We are going to, when you take the sequel to this course, 2101, in the winter, most likely, you're going to definitely learn about the data structure called stack more thoroughly. but I think in order to understand the call chain and also how the exceptions really work in Java, you have to somehow get some intuition about call stack. So I wouldn't really dive into too much theoretical aspect for the stack, but I'll give you enough intuition and some observation that's going to help you on understanding what's going on. Okay, let's try. It's going to be very much example-based, but you can easily generalize them when you think about exceptions. Let's now make the following assumption. Let's say we got 3 methods here. We got M1, we got M2, and three methods. So don't worry about being a void or not void. Okay, that's not the point here. And then let's say somewhere inside M1, we are trying to call M2. So before we call M2, we actually got some lines of code to write. So whenever I got any horizontal line, I mean they are not really a method call. Whenever you have a method call within a method, you have to somehow do something a little bit different. The simplest scenario would be if you just got lines of code just throughout without any method call, then you're done. From top to the bottom, execute the code. Okay? Similarly, you got M2 here and, you got M2 here, and then you execute some line, and then you got some method call. And we're going to do something different here, and then after that, we're going to go for the rest, okay, etc. Now we want to understand exactly the call sequence, how the lines of code in these 3 methods are going to be executed. So we're going to number them in the chronological order, in the timing. And we are going to start the execution from M1. So I call this the entry point of execution. Okay? M1 is the entry point of execution. We're going to start with this. Okay? And we are also going to trace the code with the help of a stack, which you will find very helpful. Okay? Let me give you a little bit of look ahead, how the stack is going to work. Very straightforward. Whenever you want to put something onto the stack, we call it push. So whenever you want to add something to the stack, you can also use the word push. But that's more specialized. If you don't use push in this course, I don't mind. That's OK. Or if you want to remove something from the stack, the correct term is called pop. Now, when I use, I might just say push and pop, right? But you will know what I mean. I really mean add and remove. Because when you add something to the stack or remove something from the stack, you got to do it in a very particular way. Okay? Let me give you a look ahead. If the stack is empty, you're simply going to add something to it. So I'm going to put it here. If I want to add a second item into the stack, I'm going to stack it on top. If I want a third one, stack it on top, and etc. That's how it keeps growing. Now, what if I want to remove something from the stack? I'm going to remove from the top to the bottom, the reverse order. So the first one to remove will be the top of the stack, remove it. The second one to remove will be this one here. The third one, the fourth one, the fifth one, and finally, after this one here, the stack will be empty again. That's how the stack is going to be added and going to be grown and shrunk. But we're going to see how exactly this kind of operational stack is going to help us trace the method call, especially a chain of method call. Let's now start with the M1, right? We'll start with this. First of all, we do this line first, so that'll be number 1. Oh, sorry, just before that, always remember, since this will be the entry point of execution, so we should put M1 onto the stack first to say M1 is now being executed. As soon as M1 terminates until the last line, then we can remove it, but not yet. Okay? Another thing I want you to also ask yourself, what's going to be the chronological order of calling the methods? And what's the chronological order of finishing the methods? Okay, 2 questions here you want to think to yourself. What's going to be the order of calling the methods versus finishing the methods? Are they going to be the same, or are they going to be in some particular relation? Okay. Let's now try this. So I already put M1 here. That means currently M1 is being executed. So first line to execute will be this one. The second line will be, I want to make a call to M2. As soon as I have a new method call, like in M1, I'm going to push it to the stack. Now, What does it really mean for the stack right now? That means this M2 over here is currently going to be executed. M1 sitting underneath is now being suspended. That's what we said, okay? While M2 is being executed, M1's execution is suspended, which means it will be resumed later. You will see that. Suspended. So that means the next, so this will be number 2. What about number 3? Number 3 will not be here, not yet. All right? Because we are now going to execute M2, which is on the top of the stack. Now let's go into M2, like a step into. Number 3 will be here, the first line in M2, right? And then number 4, and then number 5. Now number 5 is yet another method call. In this case, what should we do? Should we continue to here? Not really, right? Now we should really push M3 over here into the stack. M3. At this point, M3 is the top of the stack, whereas M2 and M1, their executions have been suspended, right? What about number 6? Well, number 6, we should really go to M3 because we are currently executing M3. 6, 7, 8, 9, and 10. Now we are finishing the execution for M3. So M3 is basically done. If it is done, we should really tell the stack to remove it so we can get back to the last one to be resumed. So we're going to say M3. Okay, so let me say at this point here. M3's execution finished. Pop it off from the stack, meaning that we can get back to M2 that has been suspended. So M3 is going to be gone, right? So now the top of the stack is M2. So we're going to resume to where we suspended M2, which will be here. So now it will be 11 here, and then 12 here, right? At this point, we are done with executing M2, so we can also remove it from the stack, which will give us M1. So now we should resume M1. M1 used to be suspended at this point when we call M2. So now to continue, it will be 13, 14, and 15. Okay, I hope I didn't make any mistake. Guys, does it make sense about the execution here? Yes? I wouldn't think that way, actually. So don't really think about this like an iterative process. Think about when you're tracing the code. Every time you have a method call in a method, you want to branch out to somewhere. And then once that branch has been done, you will resume from where you are. That's how you want to think about it. Yes? Each method or? Yes, you can think about it. Yes, of course. If you want to think a little bit more lower level, when I said, for example, let's say we are done with this. I said we'll just resume where we are from here, so go on. Yes, there will be some kind of address called a program counter being stored out there for us to keep track. But we don't really talk about lower level detail in this kind of tracing. You just have to know, because I know this is where I suspended M2 in order to finish M3. So now that M3 is finished, I can just go back to this point. That's how we think about it as a human. But if you study, I guess maybe 2021 computer organization, you may have to study something called program counter. Yes. Yeah. All right, let's now make some observation, if you guys are okay. Right? Let me now try to redraw the stack a little bit. This is a stack. At some point, we got M1 first being called and then suspended. We got M2 suspended as well. We got M3. This was the maximum size for our stack for this particular example, right? Let's now make some observation, which will be very useful for the intuition about stack. So number one, you want to think about what's the chronological order. Chronological order of calling the methods. It's going to be go this way, from the bottom to the top. All right, it's going to be M1, first call, followed by M2, followed by M3, right? That's what I meant by chronological order. M1, M2, M3. Okay? And we said over here, M1 is the bottom of the stack. Oh, you know what? Let me just draw another one so you can see the more general layout. If this was my stack, right? The bottom item here, this might represent a method call. This is called the bottom of the stack. You might get as many method calls as needed for our particular tracing, and they will be the top. This is called the top of the stack. Okay? And let's now say more. What's really so special about the bottom of the stack? M1 here. This one here, two things I can say. It was the method that's called the earliest, right? Because that was the entry point of execution. It was called the earliest. At the same time, can you tell me which one was called the latest? Should it be M2? No, M3. Because the fact that M3 is higher than M2, that means M3 was called later than M2. All right, so the top. All right, M3 here would be, it was called the latest. That's about being called, the timing, basically from bottom to top. All right, let's go the other way, from top to bottom. In terms of the finishing of the method, right? You can see the very first method that we saw finish was after M3 because M3 has no further method call. So once we get to here, we finish it, we pop it off from the stack. So that was the first one that was finished completely. So think about the top of the stack over here at the same time. M3, it was finished the earliest. And symmetrically, M1 here, the bottom of the stack, it was finished the latest. All right, you can definitely see the symmetry here. So we talk about in terms of the finishing, and we talk about in terms of being called, right? You want to watch out for what I'm asking here, right? And of course, if you got any methods in between, that's something you should also know, right? In terms of the direction. Later on, since your classmate mentioned about recursion, when we learn about recursion in the final few weeks of the course, we're going to need also stack to help us understand how recursion works, right? I'll get to it, but understanding in a simple scenario like this will definitely help for later. Any question about this? Yes?
What's related to the previous slide with callers and colleagues? So like M1 would be a caller.
Okay, good. Yep.
Should it be a caller of M1?
Why don't we annotate that? I like that. Okay, let's make that connection. I like it. Yes. So here, let's say as far as this method call is concerned, let's say this one here. Okay. So here, apparently, M2 is being called, so it will be the callee. M1 is calling it, so that'll be the caller. Let's move further. Let's say when M2 is now being executed, we can see as far as this particular method call is concerned, this one over here, who is the caller? M2, right? Because now M2 is where that method is being called. So you can think about M2 over here is now the caller. M3 is now the callee. We just see another example where you can see M2 here can be a callee. It can also be a caller, depending on the context you're talking about, right? Okay. Sorry, say it again. M3 here? Yeah. Well, basically, there's no method call, so there's no caller-callee relation. Think about you follow through every line of method call to find out each caller-callee relation. Yeah, I'm glad you asked. All right, any question about this? Yeah, I believe that's everything I would like to mention about a stack. But if I can think about more, I will definitely go back. But I think this will be good for now, for stack. Okay, so let's now move on to some slides. Yeah, the bullet points are pretty dry. I will try to go over a few points and then I'll go back to the diagram to refer to them. I think some parts, it might make more sense after you have studied a bit of the example and come back. The points will make more sense to you. But let's try as a first go. You got to read it first time first. So the execution of a Java project usually starts from the main method. Well, let's say you got a console tester. There could be another case over here, which is implicit. If you run your JUnit test case as a Java, if you run your Java class as a JUnit test, in that way, it will be the entry point of execution. That's just another possibility, right? Either way, but similar idea. All right, so each line of method call involves the execution of that method's body of implementation. Okay, this simply means when I say I want to call M2, I'm invoking this method. That means I'm going to execute the body implementation one by one, accordingly, right? That's what that line is saying. And the body of the method may involve method calls, right? What does that mean? So now, if I try to call this method here, M1, at some point I'm reaching a method call. And then to execute that method there, at some point I reach a method call again, right? Just keep branching out. That's why we need something special to keep track. In this case, a stack. Okay. All right, so that's why it's very typical to have a chain of method call. So you can see one chain over here is M1 followed by M2 followed by M3, right? And we can visualize by more example. And for this banking example here, I'm going to leave that to next Tuesday. So whatever I cover until today is going to be what's going to be covered for your written test number 1. But I'm going to cover the example on Tuesday. Okay, so this one, the closer a method is to the top of the call stack, the later the call is made. Well, that's really what we said. For example, you can see here. You can see this is the top of the stack. So this one was called the latest. And the fact that M2 is higher than M1, that means M2 was called later than M1 was called. Right? That's quite obvious from the diagram. You just want to make sure you're really convinced about how things work in a stack. Okay. All right, so my plan would be I would definitely like to dive directly into the exception to give you some principle and also go over some code example together with you. So my suggestion is as follows. From your slide number 5 to slide number 9, I'm going to revisit them from Tuesday, which means they are not covered in your test. I'll update your written test number 1 guide a little bit later tonight, but you can make a note yourself if you want to. So the slide number 5, which is really about how to compare exceptions versus console tester for error, right? There will be something worth noting, but let's do that on Tuesday. So it's not covered in your test. So we're going to skip for now slide number 5 to slide number 9, and then I'll go on from there. Okay. Okay, let's see here. Directly, what's really an exception? Let's go from there. And good. Let's go over some bullet points, and then I will also got some nice diagram to really illustrate many interesting ideas together with you. And of course, assuming that you kind of understand what a call stack is, which we just illustrated. I'm going to use something here. You can find the same diagram on your lecture site as well if you want to maybe annotate yourself after the lecture when you study. And there is really a stack. Let me just draw that into the context here. This is the stack. Okay? Over here. And then, not surprising, this will be the bottom of the stack, one method here, another method, another one, and another one. This will be the top of the stack. You can think about, this is the main method. Let's call it main. And this method here, let's call it M1. Think about M1, M2, and 3. Basically, it's a call chain of 4 methods here. I'm going to use this example here to illustrate several bullet points from the slides. And also, I'm going to explain some principle you want to keep in mind right away for how the exceptions will work in Java before we see the actual code. Because if you don't follow the principle that's set out by the exception mechanism, you're going to get compilation error in Java, in Eclipse, which is not very pleasant. Okay, let's go over some bullet points one by one. So what's really an exception? Exception is like an event where some error occurs. And where can the error occur? Whenever you're trying to execute the code, of course, and you're trying to call a method. When I'm trying, let's say me as a caller, I'm calling some other method. My callee may complain about some error from the input. In that case, it might disrupt the normal flow. Okay, I want to explain this word very carefully here. Disrupt. That's a very meaningful word here about exception. Whenever we talk about exception, that means your normal way of executing your code from top to bottom might be disrupted, right? Either with the disruption or without the disruption. Let's now visualize this together. I'll put it, how about here? Okay, let's go develop this from scratch. You really need this idea to begin with. Otherwise, you will easily get lost when I talk about the code. All right, so we talk about exceptions. And then it may, oh, how about this? When occurred. Normal flow of execution disrupted. Of execution will be disrupted. Okay, so this is really the principle I would like you to remember over here. When they occurred, that means it will be disrupted. If it doesn't occur, it will not be disrupted. Right? Two possibilities here. Let's now sketch the two possibilities. We should call this normal scenario versus abnormal or exceptional scenario. Or exceptional. And we're going to consider the same block of code to see how the execution should really go. All right? Let's bring back our familiar class, let's say C1. C1. All right, and then I'm going to have a method, let's say M1. Let's say it's a mutator, doesn't matter. The body of this method here, let's say we start with 2 lines without any method call. And then we are going to create an object of type C2. This will be new C2. And after that, we're going to make a call. And you should now know who the caller is and who the callee is, right? Well, think to yourself as well, just to confirm. So we're going to say O.M2, let's say. After that, we got 1 line here and 1 line here before we terminate or finish M1. So how many lines of code do we have for M1? 1, 2, 3, 4, 5, 6. 6 lines. All right? And let's now make it even more organized. All right. All right, and I'm just going to make a duplicate of this code here, and so that we can see how things work. Okay, let me just duplicate this. Sorry, let me do it again. Paste. There we go. Right, the same block of code. All right. And the one to really pay attention to where the 2 possibilities might come from is the method call. So if you look at these, this line here, either this line here or this line here, the same line. All right. Possibility number 1. Let's say when we make this call, the callee doesn't complain about any error, so no error. meaning that no exception, and we say no exception thrown back to the caller, okay? No exception thrown back to the caller. And then we have another one here. Case number 2. So let's say in this same method call here, let's say some error actually occurred when we try to execute a method call, some error. So this would mean some exception will be thrown back to the caller. Here. All right, 2 possibilities. And we're going to see for each possibility how the execution flow is going to go. That's important. Let's start with the normal one, which is not too bad. So for the normal one, it's going to be number 1, number 2, number 3, number 4. Of course, if we want to trace further, we can do what we did earlier to trace further into M2. But let's not worry for now. Okay? After finishing M2, normally, without any exception, we can definitely go to number 5, number 6, right? Very, very straightforward, sequential, top to bottom. What about abnormal scenario? 1 here, 2 here, and 3 here, and 4 here. At this point, the same as the normal situation. But now, O.M2, we said, is going to throw some exception from the callee, which is M2. In this case, what's going to happen is the rest of the flow is going to be disrupted. We don't execute it anymore. Somehow it's bypassed. And we'll see that in the debugger when we develop the actual code. But conceptually, you should really know, when I'm trying to call the method here, if some exception occurred here, then the rest of the code will just be disrupted. They will not be executed anymore. No, and no. So they will be bypassed. Bypassed because the execution flow is disrupted. All right? Conceptually, really have to be clear about the normal versus abnormal. Right? Things might get slightly more complicated when we see the actual code, but more or less this will be the principle. All right? Any question about this? All right? Hopefully that's clear. That's very good. And why don't we move on? Okay. Knowing this, let's now go back to that diagram that I spoke about. Oh, and you know what? I'll switch to the diagram. Sorry. Just give me a moment. Okay, let's now move on with the slide. So whenever there's an error occur within a method, so now method might throw an exception and etc. So this part of the slides, you can refer to it a little bit later. Every time if an exception occurs, that means some exception objects using the new keyword must be used and thrown. I'll show you how to do that. And then once the exception has been thrown from the top of the stack, which I'll visualize to you, how is the whole process going to proceed? There will be several possibilities, which I'm going to explain to you. So for this slide here, I will assign that to you for you to read because I'm going to visualize it on the iPad here. I think that'll be easier for you to see. But you're going to read the text as well, just to confirm. Let's now take a look. So now the call chain goes like this. We start from the main method here. That's the entry point of execution. And then main calls M1. M1 calls M2. M2 somewhere calls M3. Right? So this part over here, it really represents the order of method calls. So this part over here, the arrows, that's the order of method calls. And that goes this way, of course. So this one was called the earliest. Sorry, this one was called the earliest. This one's called the latest. Right? We already said that. And let's say now, when we get to M3, by the way, who's who is M3's caller? According to the stack. If I say M3 is the callee, who's the caller? M2, right? Right? If you're not convinced, I'm going to write it down. Try to convince yourself, right? Because M2 calls M3, right? So M2 is the caller. M3 is the callee. At the same time, if I look at these two, N1 and N2, now in this pair, N2 will be the callee, and N1 will be the caller. Okay, just another angle to confirm the terminology. All right, let's now get back to what I want to say. Let's say we get to M3 here. Some error occur, and some exception object is going to be originated from this method M3 here. We're going to see the Java syntax pretty soon. So this is where the exception will be originated. So we say that M3 is where the exception is originated. And typically, we don't really try to do anything with the exception in the place where it's originated. We simply throw it to its caller. Okay? So what we're going to see is M3 creating the exception is not trying to handle anything about the exception. It will simply throw it to his caller. That's always the case for the first gate, for the first level. Okay, always the case. So when we go from here to here, this one to this one here, M3 simply throws the exception to its caller, which is M2. All right. So now, for the remaining of the so M3 will be done, right? It will just be done. That will be it. So now the top of the stack will be M2. Now we're going to talk about for M2, M1, also the main method, and so on. They will have to be subject to something called catch or specify requirements. Okay? Let me say that. It's called catch or specify requirements. Yeah, you can see the full name in the slides, but I'll just say specify requirements. What does that mean? When I get to M2, let's say, right? M2 is now being forwarded or being propagated the exception from M3, right? It's being thrown exactly to here. M2 has two options over here, catch or specify, right? I'll write it down. M2 can either specify it or it could catch it. It has to choose exactly one option here. It cannot choose both, but only one option. You cannot choose none either. Okay? What does specify really mean? Specify is a lazy option for this particular method here. It's saying my callee M3 just gave me an error. It wants me to either catch or specify, but I don't want to handle that. What I'm going to do is I'll simply propagate this further into my caller. So I don't do anything about it. So I'll just choose a specify option. That's option number one. Specify. So you will see that this is simply just propagated back to the caller of M2. So here I'll just say M2 chose to specify, which means to propagate the exception back to its caller, M1. And after it's being propagated, M2 is also gone from the stack. So now we only got M1 and main left. Okay? Now what about M1? Again, it is also subject to the catch or specify requirements. Either catch or specify. Let me write down the option here and we'll see. Either it can specify or it can catch. Not both. If M1 chose to specify like M2, In that way, it's not going to handle the exception. It's simply going to propagate it into the main method here and let main choose either to catch or specify and so on. But in this case, it chose to catch, let's say. If it chose to catch, now I'm going to use, how about green? It chose to catch. So catch means M1 is going to handle the exception using the so-called try and catch block, which I'm going to show to you. It's going to handle the exception right in this place and without propagating the exception further. You can see the arrow goes back to just M1 itself. It does not go further to here. It does not. Okay? And now here's a very important thing for you to see. Okay? So now this arrow here, we should understand it as M1 handles, chose to handle. The exception. And then the consequence is very important. I want to really emphasize this. But you want to, first of all, see that this is really the catch option, right? It chose to handle that. The consequence is, since the exception is handled in M1, further callers, meaning that all the callers underneath M1, right? In this case, only the main method, right? And main is the caller of M1. So I'm now talking about main. Further callers are no longer subject to the catch or specify requirements. Catch or specify requirements. And what I'm saying here is the most important point to notice. Since the exception is handled, further callers are no longer subject to catch or specify requirement. So let me say it again. When the exception was originated from here, typically it was just being propagated to its caller. Okay, that's number one. Number two, for all the subsequent caller, until the exception is actually handled using try and catch block, every caller should be subject to the catch or specify requirements. For example, M2 over here will be specified to specify or catch. Will be subject to specify or catch requirement. In this case, M2 will choose to specify lazy. I'm not going to handle it. I will propagate it to my caller. So this caller here is still subject to the catch or specify. It has not been handled. And M1 here takes the responsibility to say, I'm going to catch it. And then I'm going to handle the exception right at this level. And once this has happened, all the subsequent callers in the stack is not going to be subject to the catch or specify requirement anymore. Right? It's a very important process for you to see. Okay? You want to know when the catch or specify requirements will actually start. The answer is it will typically start in the very immediate caller of where the exception occurs. Okay? And where should the catch or specify requirements stop? It should be until the very first method which chose to catch the exception that's being propagated from all the previous callee. All right? Every word I said here is precise. You want to make sure you really understand. Here. If you only follow 50% today, not bad. I would say the first time you're listening to exception, it's tricky. Take some time. But make sure you really review what I'm saying here. Nick, I'll take question. Go ahead.
So what happens if none of the methods catch?
Good question. What if none of the methods would choose to catch the exception? Let's see that. Exception was thrown here, propagated to here by default. Let's say this guy here, lazy, propagated to this guy, lazy, propagated to a main. And the main method say, no, I don't want to handle it. Let's propagate to further. Now, nowhere to go. It's going to be thrown to the console, to the user. Very bad. Right? Okay, that's your answer. But I'm going to illustrate this on Eclipse, maybe not today, but on Tuesday. It's a very good question. Okay? Somehow the exception being thrown has to go somewhere. It better be one of the callers in the stack. It better not be none of them wants to handle it, but it's going to be thrown to the user on the console. Very bad. Mm-hmm. Yes?
Do we
Yeah.
choose whether it's a specify or catch, or every method is assumed, or like the default
Ah,
specify?
Okay,
It's just the-
very good question. So for each method along the way, so should we do catch or specify? I would say it really depends on what you need, really, on the application. I would say, but the principle is simple. Let's say if I'm currently implementing this method, let's say, if I'm doing this, if I throw an exception, typically I don't handle that right away, typically. If you want to, because your application needs it, go ahead. I'm just saying typically. Let's say if I'm implementing this particular method. So now I'm getting some exception from my Callee. Should I catch or specify? Again, I have to decide. Am I able to handle by using some code over here? Or should I just say, okay, I don't want to handle. I want to throw it out. It's really a no right or wrong. You just have to know, depending on what each method will choose to do, how the exception is going to be propagated to which level. That's something we should know. Whether for individual methods should you specify or catch it is up to your choice. No right or wrong.
Or was like, is there a default, like, or do we have to physically program it?
You have to physically program it. You got to explicitly say you want to specify or catch, which we'll see. Yes, maybe that's what you meant. Yeah. Yeah, you have to, for M2 here, even though M2 is so lazy to specify, but you got to specify it explicitly. You cannot just say, I don't do anything, right? All right, any question? Yes, go ahead.
What I understood is that when you say it's like some kind of like a special return for like a method that is just like kind of keep in there, but like when it like does that, it's you know both like the return is like.
Yeah, I think in some way, if you think about getting the return value from the method you call, you can think that way, but I wouldn't say that's the most helpful way to get intuition. It's not exactly the same, I would say, so let's not get too much confused. So I would say maybe think about the stack over here and think about how far you can go until you actually handle the exception. It's important, okay?
And so that and also the SS rate is the one that like kind of like trace the code like back and see. Like,
Yes, exactly. Yeah.
console it shows that like this exception happened like that.
Exactly. So the stack over here is actually very valuable because it allows us to go tracing the right order. Because when I got M3 throwing the exception, which will be the method which will receive it next? I know it's M2 because M2 follows that, right? All right, guys, one more thing to emphasize. Make sure you really understand the pink highlight over here to say once the exception has been handled using the catch option, the following caller should not be subject to this one anymore. All right, that's the most important point. Please understand that. But let's now do some example. I think we should. Okay. All right, I think catch will specify. Yeah, you can go through that. That's just some example here. And we should really go through some code example. Before that, why don't we take attendance quickly? Okay. Okay, we've got about 15 minutes. Let's see what we can do. All right. About before the lecture? How about we discuss that after class? That might be better for this one here. Okay, thank you. Okay, so let's now talk about some example here which are going to develop from scratch. So here will be the code structure. We're going to have a class A with MA. We have class B and method MB. We got a tester which has a main method here. So let's see how the call chain is going to look like. Okay, so we're going to start with the tester over here. And that one has the main method. This will be the first caller we're going to see. So that will be put onto the stack first. Tester.main. And over here, we're going to make a method call, right? B here, OB, MB. Right? So this will be the callee. So B.MB is going to be the next one on the stack. And then if we try to trace further, you can see under the context of B and MB, sorry, wrong color. B and MB, we actually got A and MA, right? So that will be the next one. So that will be A.MA. That will be the top. A.MA. At some point, we want to somehow signal an error from A. I'm going to show you exactly how to do this in exception. Okay? So think about the MA here is like this top method here, which is going to throw some exception. Okay? Let's now go to Eclipse. The source code has already been made available to you. Let's now see how much we can do, right? So if we go to Eclipse here, and I'm just going to create a new package called version number 1. And we'll do other versions on Tuesday. Version 1. And then I'm just going to create class A first. And then from there, let's see how the error can be thrown using an exception. New. Oops, sorry. Wrong button. Right click, new, class. And then class A. And then let's simply use the default constructor for class A, so we don't need to worry about it. And let's have a method here. Let's say void. Let's not worry about public. Method A. And then it's going to take some input, I. We want to say something like, if the input there is negative, then we want to give some kind of error. Otherwise, we're going to proceed with some normal code. Do something in normal case, if there's no error. Okay? How do we throw an exception to signal an error? So this will be the new syntax you have to learn. Use the keyword throw, like a verb. Oh, sorry, I should have spelled it right. Throw. T-H-R-O-W, like a verb, throw. And then here we can use anonymous objects. Throw, new, and for the exception, we can create our own exception. This will be the practice you will have to do for lab number 2. All right, so you definitely got enough time to study for that before lab number 2. Let's say the exception I want to have is negative value exception. I can make up the name right away. And typically, for the constructor, it should take some string message. I can say negative value, and then plus the value of I, right? Just to give some meaningful message at some point. And not surprisingly, you can see here, if you move the mouse over, it says that this particular negative value exception is not resolved to be a type, meaning that it doesn't exist. And I would suggest when you create an exception class at this point, do not just create yourself, like a right click on the package and create it. Eclipse has a way to automatically generate it for you. I would suggest that way. The first hit here is to say create class negative value exception. Click on that. And then don't change anything, just say finish. So this is a class that's created automatically by Eclipse for you. And this part here should be no surprise to you. It's a class. Don't worry about extends for now. In written test, I'm not going to ask you to write the exception class itself, so you don't have to worry. You just have to know how to create one. Extends has to do with inheritance, which we'll cover later in the course. And because we are calling the constructor, which will take some string arguments, we want to define that constructor as well. It's overloaded. So here we're going to say public negative value exception. Some string message, and over here, this line of code also is going to use something we're going to talk later called super. Also has to do with inheritance. You also don't need to worry. For when you do lab number 2, you can simply follow this skeleton over here to create your exceptional classes. Okay? And I will explain what extends and super really mean later, not now. All right? That's about creating your exception class. All good? Let me close it. Now we do have it. However, I have an error in line number 7, the whole line. Let's move the mouse over. It says the following, on handle exception, right? Basically, it is saying that in this class over here, I'm throw an exception, but I have not handled it. All right? Strictly speaking, in this class over here, in this method here, I can either do catch or specify. But as I said, typically, in the place where you simply create the exception, you don't really catch it. You specify it. Let's see that. So I'm going to propagate this to its caller. How do I do that? So I'm going to do very easy thing. So now to specify it, I want to specify as part of the header of the method in line number 4. After the parameter list and between the curly brackets and the parentheses, I would say another keyword here, throws not throws that particular exception. And it's fixed. This is saying any caller of this particular method should be aware that this method here may or may not throw an exception depending on how it works internally. So any caller of this method here, from now on, they are going to be subject to specify or catch requirements. All right, good. Let's now go on to the next class. Okay, and then we'll go to the next class. Let's say we go to class B. All right, and now we'll go to class B again. Let's now create a method here. Let's call MB integer I. I just want to call MA. A, OA, object A, new A. And then now I will be subject to catch or specify requirements. So if I say OA.MA, and then I'm simply passing I got an error. All right? If you see what the error is, it is called unhandled exception. Not surprising, I need to handle this exception here. It would be like in this diagram here. This exception has been propagated to here. I'm now here. I should either specify or catch, right? Let me show you the catch option. Okay? The way to catch it is by using the so-called try and catch block. I can try and catch. And then when I say catch, within the parentheses, I need to declare the exception I'm expecting to catch. In this case, it would be the negative value exception. I can copy its name. All right, let me go back there, and then I'll put it here. And then you want to, as if you're declaring some parameter, so you can refer to it if necessary. Negative value exception. Okay, like that. And then I'm going to say, now you want to put this method here that was triggering the compilation error into the try block. Okay, and then now everything's fixed. And remember what I said before. After, it will be as if this method here, which shows the catch. After this, if there's any caller that is trying to call this method here, because the exception has been handled already, the caller would no longer be subject to catch or specify requirement. I'll show you what that means in just one moment. Let me just put a few more lines here. I can say system.out line. And I can say the negative value exception did not occur. We're going to trace it. And here I'm going to say because I entered the catch block, that means it occurred. Negative value exception occur. I'm going to use these two lines to really illustrate some execution flow, two possibilities, right? Bear with me. Let me now create one more class, which is going to call MB. And remember what I said, MB right now does not specify the exception anymore. It handles that already. That means any caller of MB, they will no longer be subject to that requirements anymore. They don't need to either catch or specify. Good thing. Let's see why, or let's see how. All right, new class, let's call it a tester. And this will be the final method, so, final class, so let's put the main method there. Okay, and now, oops, sorry. There we go. Okay, let's say B, object B, new, B, here. And now if I say ob.mb, pass some integer, for example, 23. Did you notice one thing? There's no compilation error. It does not say anything like an unhandled exception, right? That's exactly the point I highlighted and want you to watch out for. That's really corresponding to this guy over here. Because in class B, I already handled that exception using the try and catch block. So now in the tester, in the main method, I'm no longer be subject to that catch or specify requirements. That's really the point you want to remember. At some point, somebody has to handle that exception. If nobody, you'll be thrown to the console. All right? Now, finally, I want to do two things. I got 4 minutes. All right? We want to do some tracing. OB dot, let's say MB minus 46. Okay, let's do that quickly. I'm going to put a breakpoint in line number 7 over here. Right? I'm going to step into to see what happened. Let's say launch the debugger. In line number 7, because it's a positive number, we know that it's not going to trigger any error anywhere. But let's try. Okay, switch to the debug perspective. Okay, let's now step into this method call. Sorry, my machine is a little bit slow. There we go. Let's now step into. Okay, 23, just remember. If I say 23 over here, now I'm now in MB. This is the place where I am doing the try and catch block over here. So now I want to know, okay, let's just step over one. Now I'm calling OA.MA. And what's value of I? 23, right? You can verify that. Question for you guys. What's the execution flow going to continue? After calling this method here on line number 7, am I going to go for the normal flow to line number 8? Or somehow it's going to be disrupted and go to the catch block in line number 11? 8 or 11 or something else? 8, good. The good intuition, but let's verify that and then I'll show you how you can trace it. If I do step over, correct. All right, let's do it once more. And by the way, line number 8, and if I say step over again, am I going to line number 11? Now really, you either go to try or catch. You don't go both. If I say step over again, I'm now done. Okay? Catch is bypassed. Let me do it once again, okay, just to show you. I launch the debugger again. I got 2 minutes. We should got enough time to do a few rounds. Okay, let's now step into. And then we're now in MB, and in this method call here, and we know that we're going to go to number 8, but why? Because exception did not occur. Why did it not occur? Let's see. If I step into MA, that was a condition here, right? You can see I here is 23. If you add on expression here, 23 less than 0, false. That means we're going to bypass the creation or throwing of the exception. If I say step over, nothing. Right? But of course, you can put some line in the else part if you want to. But it's simply not throwing the exception. So that's why we'll simply go on to line number 8 as we predicted. Right? Let's now see what's going to happen. 2 more, and then we should be done. What's going to happen if we try to put a breakpoint in line number 8? Minus 46. This should trigger some exception. Right? If I try to launch the debugger again, okay, let's now step into. Good. And now, let's pause a bit. I here is now minus 46, right? We would expect some exception to be thrown from the Callee MA because it got the if conditional, right? Now, do we expect to go to line number 8 or go to line number 11? 11, right? Because exception will be thrown. Right, let's now step over. Exactly. All right? If you don't mind, one more run, and then I'll let you go. Let's see exactly how the exception occur to be complete. And now one more run, and we're still going to do the minus 46, and then I'm going to step into it. And then let's go on to here, and now step into it to see how the exception occur. Step into it. So now we got I less than 0. So I is actually minus 46, which will be true, right? Oops. 10 seconds, how about that? And if I step over, this is where the exception is thrown. Okay? Step over, and that's exactly how we get to the catch block, and then go to that line. Thank you so much. I'll update the coverage for written test tonight. See you later.